everybody. Welcome to Junior Makers. My name is Kim. I am a community learning specialist with DoSpace. And today we have a special episode of Junior Makers today. So today we are going to be featuring two local youth makers that we have in the Omaha area. Today we are welcoming Yash and Rohan. They are two young men who are they are local high schoolers here, and remind me again which school district you guys are with.
We're in the Millard School District.
That's what I thought. Okay, so they're with the Millard School District, and they are going to be talking to us today about, they are some youth makers. Like I said, they have made some really, really cool and incredible things over the years. They have both been volunteers at DoSpace. They have both been makers at most, if not all, of DoSpace's make events. So Make Omaha, when we were doing maker fairs, they were participants for that, and they have made some really amazing things, from 3D printed prosthetic hands to transforming kind of small, like kiddo kind of power cars into mobility devices with children with disabilities. And they are going to be talking to us today how they've been 3D printing some things to help with our local medical community. So this is going to be our feature today. Next month, I promise we're going to be doing some making, and I'll talk about that a little bit at the end of our program today. But I just want to welcome Yash and Rohan. And so if you guys have any questions, you guys should have an option to do either Q&A or in the chat. If you guys have any questions for them, please put them in the Q&A. Actually, I think that'll be a little bit easier for me to kind of like see what people are asking, and then I can ask our makers today. So I just have a few questions for you guys before we get started, if that's okay. So first off, how old are you? And I guess I'm going to have you introduce yourself. Let's do that very, very first. Can you guys introduce yourselves?
All right, so I'm Yash. This is Rohan.
Yep.
Perfect. And then how old are you guys?
So I'm 14 and he's 16.
I'm 17.
17 a couple months ago.
It's an important distinction for sure. So perfect. So you guys, we have a 14 and 6-year-olds. So you guys are not too much older than some of the kids that participate in Junior Makers. So Junior Makers is usually for 6 to 12-year-olds, where we do some really fun things. And you guys are not too much older than that. And so my question for you guys is, like, how old were you guys when you kind of got into making and started like tinkering and kind of figuring things out when you were starting to make things?
So I guess I'll start. My first time at DoSpace, I think it was around 12 years old. So it was like late 2015, early 2016. So it's been a while, actually. But my first project I ever did actually kind of took me a year to finish. So I started out with like an Altoids flashlight, which is a pretty common starting project. And I kind of lost interest in it immediately. But then when I was a little older, I came back to it and found that it wasn't as hard as I thought it would be initially. And it was actually really fun to finish. So it was kind of like a really cool project to introduce me to this kind of world and all the different things you can do. And then, yeah, I was around 12, 13 when I started volunteering at DoSpace for the first time.
Very cool. And Rohan, what about you?
So yeah, I was about the same age that he was when I started volunteering at DoSpace, which was like 2018, and I was 12 then. And I really started making at a young age, since around the house things are always breaking. So my dad actually helped me go around the house and taught me how to fix all these things, leading me through them. So I think I started making at a very young age.
What were some of the things that you were like fixing and kind of tinkering with?
So we started with changing light bulbs, which were constantly blowing out, and then light switches eventually started breaking. So we just tinkered with those. Recently, actually, like a week ago, the sprinkler system was broken. So we tried to fix that, but something was wrong with the pipe, so we have to get a handyman for that.
You can only do so much, right?
And yeah, just things all over the house.
Okay, very cool. And so what are some, I guess, you guys kind of talked about, Yash, you did an Altoid flashlight, you were tinkering, Rohan, you said you were tinkering with things around the house. What are some, I guess, recent projects you have been working on outside of what you're going to be talking about today?
Okay, so
Maybe in the past couple of years, we'll say.
I recently, or like a year ago, so I'm an Eagle Scout, which is a Boy Scout rank, and for that you have to do an Eagle project. And my Eagle project was to, as Kim said earlier, modify these Power Wheel cars for kids with disabilities who couldn't move on their own, and it let them take control of their own mobility, which helped them in their mental development and also helped their physical skills. So that was one major project that I did in the past year. And I'm also currently learning Unity, which is a coding language used for designing games. And once I fully learn it, I'll be working on designing games to help improve the physical coordination of, again, these kids with disabilities.
Very cool. That's awesome. Nice. What about you, Yash? Any really cool projects you've been working on recently?
Yeah, I have some, but I was, since the project I've been working on kind of have to do with 3D printing, I think I'll talk about them a little later in the presentation.
Yeah, that's totally fine.
Yeah.
Perfect. And so I guess for you, like I said, we have a lot of younger kiddos, young makers that come into Do Space and, that are similar ages that you guys, when you started volunteering and are kind of exposed to how to make in all the different ways. Because, when we say making, it's such a broad term, right? It could be from, just, helping out around the house to creating something in code to doing things with circuitry to making things with cardboard. I try and kind of span a whole different type of like making in junior makers. And so I guess what are some things that you can do to encourage other kiddos, like maybe around your age or younger, to like get into making? Because sometimes it can be a little bit tricky, right?
Yeah. Yeah, definitely. It seems overwhelming at first, obviously, with just the breadth of what you can do, especially at Do Space. But I feel like the best advice is just to start with one small project, like one part of a project, and then if it goes well, then like move on to like bigger things. But like I guess just start small within your means.
Yeah, and don't be discouraged if this first project doesn't pan out. Just find something else if the first thing doesn't work. And eventually something will work and it'll feel great building something and seeing this whole new thing that you've created, like by yourself. It's really a great feeling.
Oh my goodness, I totally agree. It is a really great feeling, especially when you kind of are frustrated or something isn't going well and you can't quite figure it out, and then something clicks and then it happens, and you're right, it is such a really great feeling. So I think that's really a great advice just to keep going. Perfect. Well, you guys, I think I would love to hear about what you guys have been doing. You guys have been really active, over the last couple months. We're kind of in this weird pandemic mode where people are staying at home. We have a lot going on outside the world, and you guys are, even though you are at home, you guys are helping the Omaha local medical community. And I think people would love to hear about what you guys are doing and how you are helping our local medical community, and maybe what are some other ways, like if you know, like how can we all help if you know. And I forgot to prompt you on this one, so if you don't want to answer it, that's fine. But I want to have kind of you guys go ahead, and I know you have a little presentation for us, and so I'm going to kind of give it over to you and let you talk about what you guys have been doing over the last couple months.
Okay. So I think we'll just start with the presentation.
Yeah.
Yeah. And again, if any of our attendees have any questions, feel free to put it in our Q&A or our chat, and I'll make sure that our Yash and Rohan get asked that.
Okay. So yeah, we're talking about, I guess, we're starting with just 3D printing in general and like what 3D printing is about, and then moving into 3D printing personal protective equipment, to stop the global pandemic.
Yeah. We're also going to go over some other projects that you can do.
Yeah, or some uses of 3D printing, kind of what we've used it for before. So yeah, we talked a little bit about ourselves already. We're freshman and senior at Miller North High School. We both actually are Eagle Scouts and have done different Eagle projects. And then we ordered like a 3D printer kit and have built our own 3D printer. And then we've just been interested in technology for a long time. So I'm going to talk a little bit what is 3D printing in general before kind of going on to the projects one can do with it. So 3D printing is a method of manufacturing that uses melted plastic to form different layers, and as the layers stack up, it kind of forms it forms a new shape or whatever you want to manufacture. It's also called additive manufacturing. So you kind of add to a base to create something. And the design of this this piece that you want to create comes from a digital file that's sliced into layers, and then a computer is able to control like the temperature that the 3D printer is at, how fast it can print, and like where it's supposed to print. So here's a picture of a 3D printer and the different parts of it, the more important parts of it. So the extruder is the part that heats up and like melts the plastic. So I think, yeah. So the plastic comes from this kind of spool. It's like a spool. I don't think we need one. It's like a spool of thread basically, but just plastic instead. The plastic is fed up into this wire and into the extruder, where it's melted into thin strands that are placed down on this heated bed. This heated bed usually has some method of adhesion to keep like the print from moving around. The filament obviously is the plastic that's melted. The controller is where you input the files into from the computer so that the printer knows where to print. Fan cools down the print as it comes out so it can harden almost immediately. The frame is just obviously to keep everything together and everything standing up. The object is what you are printing. And then there's different motors around, some down here and then some up here to move the extruder up and down and move the print bed back and forth.
Okay, so to begin with, what do you need to start 3D printing by yourself? And the first main thing is you need to buy a 3D printer, which usually comes in pieces and you can assemble using the manual. You can buy it or go to DoSpace if we weren't in this pandemic. And for a small fee, you can use the 3D printers there. And the plastic that is melted for the 3D printer is called filament, and it has many forms like PLA and PETG. And some of the tools that you would use to assist with 3D printing are a scraper to get the print off of the print bed, tape to help the print stay solid as it's printing, and then glue is another method of adhesion. And you can also use pliers in case something's sticking or won't come off properly. And the main way that you download files is in the STL format, which you can make your own through programs like Fusion 360, which is a 3D modeling program, or Autodesk Inventor, or you could also download them from the internet from places like Thingiverse, where there's a huge wide collection where people from all over have uploaded their own designs that you can print. And then through slicing programs like Cura, you can change the STL file into a G-code file, which is meant specifically for 3D printing. And through this program, it converts the STL into G-code, and makes it so that once you upload it into the printer, it can actually follow the directions. So yeah, those are the main things that you need to start 3D printing. So some of the projects that you can do, these are just some nice basic ones. Like you could print your own Jenga sets, or even a catapult. And this is a nice big one, which is an Iron Man suit. And you would have to assemble it since it's so big and would take so long to print. But yeah, that's another fun project that you could do.
Yeah, it's a more complicated project that even we aren't as experienced yet. But the possibilities with 3D printing are really endless. Then we'll talk about some projects that we've actually worked on in the past that like have a greater impact than just like a Jenga set. So I talked a little bit about prosthetic hands earlier. And so for my Boy Scout Eagle project, I 3D printed prosthetic hands for children with upper limb deficiencies. And so this was a really cheap alternative for people who needed prosthetics but would like quickly outgrow them. And so 3D printing was the perfect choice, or the perfect medium to create these kind of hands. Each piece is individually printed and then assembled, but for a really cheap price. And they're surprisingly functional for like how easy they are to make. The harder part is actually putting it together rather than like the 3D printing of it. And then over here is a Open BCI headset, which stands for Open Brain Control Interface. So it has electrodes that are able to read brainwave activity and then transmit it to a computer. And so the entire frame of this, all the black and red pieces, were actually 3D printed on our own printer at home. And this kind of shows the power of 3D printing, how intricate designs it can make, and what they can be used for. And so we're still kind of working on this project, which we would have presented at the Maker Faire this year if circumstances had been different.
Okay, so now we're going to talk about personal protective equipment, or PPE, which we make in the form of face shields. And the coronavirus spreads by droplets in the air, and this personal protective equipment is critical to prevent medical workers from getting the virus. And because there's so many cases, there's a huge demand for personal protective equipment and a huge shortage of supply. So one way that you can print this is in forms of face shields like these, where all you have to do is print these and then attach a transparency which prevents droplets from getting through. Because,
Yeah, this is just like a hole punch sheet of plastic that you attach to this 3D printed headband, and then those two together basically create what these doctors are wearing here, these face shields that help with protection against the coronavirus.
And they're very simple to attach. Attaching a transparency to each mask only takes a couple of seconds, and the masks are reusable.
Yeah, you can reuse the headbands and then just switch out the mask.
Yeah. As you can see, a medical worker using this would be protected from droplets in the air.
And so, you want to talk more about this?
Yeah, so we've built and donated over 600 face shields, and all I really have to do is to keep an eye on the print and start one every couple of hours. And it's really easy, and you only need to get a 3D printer and start 3D printing to really help the medical community. So all you need to do is to 3D print one of these headbands and then add a transparency, which I just showed you is really easy to do.
And also, a lot of people are talking about like selling their own masks to either donate or use for themselves. But the benefit of these transparency or these face shields is they're kind of low management. As Rohan said, he just needs to start the print, and then he can keep an eye on it, but then he can do other things while the printer is going. And so every like hour and a half, we come back and check on the printer to switch out either the filament or just start a new print. And so we can print 2 face shields every hour and a half.
Yeah.
And then we're gonna show you the 3D printer right now. Actually, it's going. So yeah, Rohan will go over there and we'll switch over the feed, I guess.
Okay, so as you can see, we have a print running right now. You can see the print bed and tape attached to it to help the print from coming off and moving around while the print is going. Can you hear me?
And
Okay, yeah.
Yash, you might stop sharing yours. Screen sharing, so then maybe we can spotlight Rohan's video. There we go. Okay.
Okay. So yeah, this right here is the print bed, and then there's just masking tape that allows you to keep the print from moving around. This right here is the extruder, which down below there's a little tip that will allow you to that allows the filament to be made into thin strips that are then applied to the bed. So yeah, it's really simple and easy to do. There's the spool over here that contains all of the filament, and then right over here is the controller. The way that we give the file to the printer is through a micro SD card that is attached right here, and through a flash drive you can upload whatever files you want to it. So yeah.
Yeah, I don't really have anything else to say about this. But here's some other face shields we've made or been making recently. I guess they're kind of stuck there, but
Yeah. Okay.
That's so cool. I guess is whenever you guys are, you said it takes about an hour and a half to make the two, right? Are you guys open? You guys are muted, I think.
okay,
There we go. Okay. No, you're fine. No worries. And so are you guys doing this 7 days a week? Are you just doing this like, how often are you doing this every day, or how often are you guys printing these?
So the days we have it running we have it running about like 12 to 14 hours a day. So we've been like waking up for school anyway. So then we start the printer at like 8 a.m. and then it usually ends around like 10 p.m. So those days we can print quite a few face shields. But then like the days we actually do that, it kind of depends on the demand. Like when we get requests from like different hospitals and medical facilities, those are the times we really have the printer running all the time. Otherwise it'll be maybe a few hours a day.
Yeah. We can print between like 12 to 16 masks a day. And yeah, it all really depends on the demand. Like sometimes if there's no demand, we just won't keep the printer running.
Or we'll like stockpile some, but
yeah,
not as many as we would if we had like an active request, I guess.
Yeah.
And how many, like whenever you're getting a request, about how many are being requested? When
it's usually like around 50 to 100, like one of those two. Yeah.
And how many, I guess, different hospitals or organizations do you think you've donated to?
Quite a few, because like it's not always like big amounts like 50 or 100. It's like individual doctors or different people requesting them, and then we have a few people that we're in contact with that they work with multiple different hospitals. So then we kind of give it to like a proxy in between who's able to distribute them as necessary.
Gotcha. And how did you get when obviously you were interested in printing these and helping our local medical community, and how did you kind of get the word out so people knew to contact you to get these requests?
So some of it was just like social media, just asking around, seeing if anyone needed these kind of headbands. But then there's also different organizations already existing within Nebraska and just around the world. But like within Nebraska, there's different people who've made like Slack group chats and stuff like that to request these kind of face shields and other masks that are necessary. And so we kind of connected with one of them and like connected with some people through there, and that's how we got people to distribute to.
Yeah, and we also, as our dad works at UP, we've gotten
Union Pacific.
Yeah, Union Pacific. We've gotten them to also help with printing the masks, and they even wrote a little article about us that would spread the word even more about these masks. And to get the designs all over the internet, I think it's on Thingiverse as well.
A few designs are on Thingiverse, but you can really find them if you're looking.
Yeah. Very cool. Excellent. Well, is there anything else you would like to share with us about, you said something at the end that you had some different ideas for people to help, or different files or something to that effect.
So yeah, people can, anyone who has a 3D printer can easily do this kind of project and then connect to one of those groups I was talking about to find people to give it to. But then donations obviously help to different organizations that need it.
Absolutely.
And then was there another one?
I mean, the only thing left really is to thank everyone who's helped us with this. We've worked with so many people and they've all helped tremendously.
Yeah, absolutely. Well, perfect. Well, I'm going to open up. Looks like we have these. I'm wondering if any of our attendees. I'm going to check our Facebook really quickly to see if we have any questions on Facebook. None on Facebook. But yeah, do we have any questions from our attendees? Anything that you guys want to ask Yash or Rohan before we finish up today? I am not seeing any questions. Well, if anybody does have any further questions, you can always ask them at hello@dospace.org. Or you can message us on our Facebook page, anything like that. And yeah, and we can always pass along those questions to Yash and Rohan to see if they can answer that. But well, perfect. Well, I guess you know, you guys were talking about how you have a few projects that you have been working on. Are there any projects that outside of the face shields, or just like any kind of like maker projects that you have coming up in the future, or that you are wanting to try, or maybe something new that you haven't attempted yet but would like to?
Rohan, yeah.
So for my project, it was making the cars, and we're considering working with circuits to add like
To extend the project.
Yeah, to extend the project, to add ultrasonic sensors, which would prevent the kids from like running into walls and stuff.
Oh, very cool.
Like there's already a kill switch so that parents can turn off the car from the back in case the kid is in danger or needs to stop or anything. But we're considering adding ultrasonic sensors so that they don't run into walls or anything and doesn't damage the car. So yeah. And then we're also working on, Yash, were you considering adding the sensors to the arms?
I think we're focusing on like we're focusing on the cars for now with the sensors, but then other projects we're working on, kind of like designing our own 3D printer files to both help with the pandemic, but then also just to get more practice with that.
Very cool. Nice. Awesome. Well, guys, thank you guys so much for joining us for Junior Makers today. And thank you so much for all your hard work with, 3D printing these PPE. It's such important work. And I know that you are protecting our medical community and saving lives, which is just a really noble thing. So thank you so much for joining us today and just being some really great local junior makers that we have in our community. We're lucky to have you in the Omaha community. So, and yeah, thank you for joining me for Junior Makers. I really hope we got some of our kind of younger kiddos inspired to see like what they can do, just like you guys. So thank you guys so much. And
Thanks
for yeah, of course. And for our members, or for our junior makers, I guess, next month or next week, we are going to be going back to making, and we are going to be talking about circuits, and we are going to be making little circuit bugs and, it's a good thing that you said something about circuits, because that's what we are going to be kind of talking and focusing on this month in May. So hopefully you guys can join us next week, next Wednesday at 5 o'clock for Junior Makers or Junior Makers webinar. So again, thank you guys so much for joining us, and I hope everybody has a great evening. So thank you so much.
Yeah.
Bye.